On September 10, 2022, Jay Kalinsky, call sign NE2Q, gave a talk and demonstration on the pros and cons of various vertical antennas for the Peekskill Cortlandt Amateur Radio Association. The event took place at the Putnam Valley Library in New York. At the end of the demonstration, keep watching, as Jay gives a bonus presentation on the history of amateur radio repeaters in New York State.
Okay, I think everybody's here that's planning to come. Thank you for coming. My name is Jay. My call sign is NE2Q. I've been a ham for a while, about 62 years, and I enjoy playing with antennas, designing them with computer software, and I really enjoy that aspect of the hobby. I operate all the HF bands, and not much 2 meters anymore. Okay, today I'll be discussing common mode currents and how they can affect the operation of our antenna systems. I'm going to make a bold statement. Every antenna has common mode to a certain degree. That's my opinion. If anybody could prove otherwise, let me know. When we talk about antennas, we should think about a whole system, not just the antenna wires. The system, it's the coaxial cable, any balance, any RF chokes, antenna tuners, antenna switchers. So that's all part of the whole system. I'm going to try today to show you how we could detect common mode current easily by using your hand. Okay. We're going to look at basically three antennas today. Okay, here's the antenna on the left. It's a half wave, bottom fed vertical, a very common antenna. Some people call it a sleeve antenna. So, this is a very common antenna. I made one about 20 years ago, and I couldn't get it to work. Yeah, I made one of these antennas 15 years ago, 20 years ago, I don't remember. Couldn't get it to work. SWR was all over the place. I had no clue why it wouldn't work. It was in the handbook, the ARR handbook, and I reproduced it just the way they said. Couldn't get it to work. Well, since then, I have learned a little about common mode currents. And I did get it to work, and I'll be showing you that later. The second antenna is the same as the first, but it has a choke on the bottom of it. This item here, that's a choke, an air wound choke as part of the coaxial cable. And that works. This one doesn't work. It's a waste of time. Well, we're going to demonstrate that. This is it. It's hanging right here. This is the actual bottom-fed halfway vertical. That's in this picture here. And the other antenna is a quarter-wave ground plane with drooping radials, 4 drooping radials. All of these antennas I have made here, and I'm going to demonstrate them all to you. So, sources of loss in your antennas. You have transmission line loss, SWR, caused by mismatches, terrain loss, and common mode current. So we'll refer to that as CMC. CMC. And what is common mode? What the heck is it? 10 years ago, I'd never heard of it. It was there. I've been operating with common mode current, but I didn't know what it was. And I didn't know how it affected antenna systems, but I have since found out. And if anybody has an antenna here, I can pretty much guarantee you've got common mode. Okay, there's all different levels of common mode. You could have just a slight amount, or you could have a lot of it. Okay. Common mode current, with relation to coaxial cable, to Feedline, this is coaxial cable, a blow-up version. This is the center conductor, and this is the shield here. Normally, you want currents flowing on the center conductor and the shield, but where do they flow? RF flows on the skin of metallic objects, on the skin. So normally with coax, the current that we want flowing, the desirable current on the shield, is on the inside of the shield. So common mode, if you have common mode, it occurs on the outside of the shield. It flows on the outside of the shield. And it radiates. Common mode current causes radiation. In many cases, it becomes part of your antenna. And you really don't want, in most cases, your coaxial cable radiating. You could have situations where if it's radiating, it's going to be radiating all along the coax, and it's going to come right into the shack. And you're going to have RF in the shack. If you ever have, years ago, I remember I had a microphone when I was operating from Lake Mohegan, which is not too far from here. My father's home, he had a summer home there. I had a metal microphone. And if I accidentally touched my lip to the microphone, I would get an RF burn on my lips. Anybody ever have that happen? Huh? Anybody? No, no one ever had that. Okay. I had no idea. I was getting common mode currents on my microphone cables. I didn't know what it was. I tried grounding it, didn't do anything. Grounding, in a lot of cases, does not eliminate common mode. A lot of people I've heard, they say, oh, I have a good ground, so I don't have to worry about common mode. That's not true. There's a, yeah. So here's some of the explanations. RF floating on the coax, on connecting cables, on power wiring. And as I mentioned, it's radiating. You really want to restrict your radiation to the antenna, not your cables. I had there's a fellow I know, he lives in Mount Kisco. He has 14 antennas up, wire antennas. I call him Interaction City. They're all wire antennas, and they're all within about 150 feet of each other. Some are only 20 feet away from each other. He has a $5,000 amplifier he purchased recently. Rig Expert, SPE 1.5 kW, solid state. He operated it for a month, and it blew out. The finals blew out. Shipped it back. The factory had it repaired. Worked for a little while. Just blew it out last week. So I was looking at that amplifier. It has 4 antenna ports on the back of it. 4 antenna ports. So he has coax from 4 antennas, which are located near another 10, all coming into the back of that amplifier. And I told him, I said, you probably got common mode. I'm sure you've got common mode. You've got RF coming down all of the shields of that coax. When you're transmitting on antenna A, antenna B, C, and D, the other three coax, all are bringing RF right down to that amplifier all over the chassis. So he said, well, I have it grounded. I said, well, doesn't mean anything. That's probably, and what I think is probably causing problems with his amplifier and the amplifier finals. And the manufacturers of the amplifiers, I don't think they realized that. I think that was a big error, putting those antenna switches on the back of an amp. Okay. Here's some of the things that cause common mode, additional things. You have an unbalanced antenna. What's an unbalanced antenna? Off-center fed dipole. That's an unbalanced antenna. How about here's a standard dipole, but the coax is coming away closer to one side than the other. That's an unbalanced system. That will cause common mode or RF to be induced from the antenna onto the shield of the coax, and it'll come right back into the shack. It will affects the SWR. Okay. Could you go back to the previous one? Yeah, you could have RF strong on one Feedline wire. Yeah, that's also because of unbalanced situation. And a consumer device can cause common mode. What does that mean? Common mode could also be called just RF radiation. A plasma TV transmits. What does it transmit? It transmits a lot of noise. An electric razor causes RFI. It can cause RFI. An electric motor from an air conditioning or a heating system or blower, that radiation can get on your coax shield. And when that happens, that noise comes right into your receiver. Some noise is picked up on your antenna, but a lot of times it's picked up on your coax. They call it common mode. I prefer calling it just the radiation from external devices. Okay, you can go to the next. Okay, one of the reasons that you'll have common mode, another reason, you don't have a choke that chokes out common mode current. There are chokes that you could make, you could buy. I'll get into that. I'm not going to get into the technical aspect of them. It's all over the internet, how to make these chokes. All right. Some antennas need some type of a balun, a one-to-one balun. Sometimes you'll go from an unbalanced antenna or a balanced antenna to an unbalanced Feedline or vice versa. And you've got to account for that. You've got to take steps so you don't have a problem with that. That'll cause common mode current also. Okay. If you route your Feedline, as I said, I showed you that dipole before where the Feedline was close to one side of a dipole, closer than the other. That will cause you to have common mode. And if you're running a Feedline, there are other antennas. As I mentioned, this fellow with the amplifier, that will cause problems coming into your shack. The antenna design, as I mentioned, unbalanced antennas. Anybody else can think of an unbalanced type of an antenna besides an off-center fed dipole? Here's one right here. This bottom fed, that's an unbalanced antenna. Feeding it, it's being fed down here. It's an unbalanced antenna. That's why it never worked for me 15 years ago. I'm going to show you that later. Yeah, you could have metal objects near an antenna. A gutter, a metal gutter, rain gutter, can pick up your RF and re-radiate it onto your feed line. So if you think you're operating without common mode, good luck. I'm sure you are. But there are hopefully ways that I'll show you how to get rid of it, or how to reduce it drastically. Okay, you can go to the next. Okay, if you have a beam antenna and you have common mode currents flowing on your coax, and your coax is radiating, you're going to have a distorted pattern. You might be pointing your antenna to the west, and people tell you, you know, I'm to the north of you, but you're stronger to the north when you point your antenna west. I hear you better when up here in the north. The same fellow I mentioned before that has 14 antennas, he has a tri-band beam on his roof. If he wants to talk to somebody in the south, he has to point his beam west. Because he's got so much stuff up there that everything is distorted. His whole beam, it's almost a joke. Anyway, but he likes putting up antennas, so some people, that's better than not putting up antennas. Okay. Common mode causes high SWR. Sometimes you can't get your SWR down. So some people will put a tuner on their coax, and they'll say, "Oh, I got my SWR down. I got a 1-to-1 SWR." They might really have 8-to-1 or 10-to-1 actually coming at the end of the coax, but because of the tuner, they bring it to 1-to-1. But they still have that SWR. They still have the common mode on the coax. They're still not operating properly. Just because you have a tuner, you see 1-to-1. That's a myth, thinking that your antenna is working perfectly efficient because I got a 1-to-1 because I have a tuner. Okay, shift the apparent minimum SWR. It'll shift in frequency. Common mode will make your minimum SWR appear at another frequency. Okay. It'll also make your SWR dependent upon the length of the coax. Have you ever heard anybody say, tune your antenna by changing the length of your coax? Ever hear anything like that? Okay. Yeah, you can do that by changing the coax length, adding a piece, taking a little piece off, and you see the SWR shifts. That's usually for a couple of reasons. You don't have a 50 ohm impedance at the feed point, or you've got common mode that's causing that problem. Okay, do we have any more slides? What was that?
If it's working correctly, it shouldn't make any difference at all if you add or take coax away. Right? Wouldn't that be a true statement?
He's agreeing with you.
What was that?
He's agreeing with you.
Oh, he's agreed. Thank you.
No, I'm saying if you don't have common mode and
Yeah.
line is matched.
A very good test if you want to see if you have a lousy input impedance at your feed point. If you don't have 50 ohms, you could add, when you put a new antenna up, add it. Look at your SWR at the end of the coax with an analyzer, and then add 3 or 4 feet of coax and see if it stays the same. If it does, then you probably have 50 ohms up at the feed point. Okay. Well, we talked about RF in the shack. And I also mentioned a perfect example of RF equipment faults. I was talking to a fellow in Australia who I speak to often. He has an ICOM 7600. He had it for a number of years, and he tried a beverage antenna hooked up to the back of the radio. ICOM has a port on the back of some of their radios for hooking a beverage antenna up. What ICOM engineering has failed to do in their design is put a relay in the transceiver that disconnects the beverage antenna from the radio when you're transmitting. It doesn't do that. So he transmitted with antenna 1. The RF got into his beverage and came right into the radio, and his finals were destroyed. Same thing happened to me with my ICOM radio.
It ruined the final?
I burned out my finals, same thing with a beverage antenna. I foolishly thought, I didn't look at the schematic, I thought they have a protection circuit in their relay that would drop out, that would disconnect it. Anyway. All right. Well, we talked about false meter readings. When you have common mode coming down your coax, that's a good source of TVI or RFI on stereo equipment, on computers. So it's best to try to get rid of common mode current. All right, how are we doing? Yeah, you could have audio distortion on your own signal. Many times people say, oh, your audio is terrible. Many times it's RF getting into your audio circuitry because of common mode current. It's getting onto your microphone cable. Okay. You could have a weak signal because the power is not coming out of your antenna only. It's coming out of your coax. It's coming into your shack. You know, the SCC, they have a voluntary a test that you can do to see how much RFI is coming into your shack, what you're exposed to. But no one ever realizes that a lot of it is coming in right along their coax line. And they can be exposed to strong RF fields, not from the antenna. Yet, back to the same story, difficult to match the antenna impedance. And as I mentioned before, you could have a lot of noise on your receiver that is caused by noise coming down the shield of the coax. For some reason, all the literature, they call all of this stuff common mode. It should really be broken up into different terminology, but for some reason, everything I've studied, everything is common mode. Okay. As a fellow I know, W2FFV, he used to live in Ossities down in Pennsylvania. I was talking to him on the air about 3 years ago, and he has phased dipoles on 40 and phased dipoles on 80, and he could switch the phasing so he could beam his signal towards Europe or towards the US. And it's very effective. And he says, you know, I always have a lot of noise. I got like an S6 noise. I said, how long have you had? He said, ever since I put the antenna up. I said, you ever put any chokes on your coax? What's that? I said, you might have man-made noise getting on your coax. He said, you're nuts. So every once in a while we would talk, and I said, you ever try that? He said, no. I said, why don't you try it? Go to Palomar Engineering and buy about 6 beads, mix 31, and slip it on the coax, the clip-on beads. He did. And he was so excited. He says, Jay, my noise went from S6 to S1 just by putting beads on. Another example, I just designed a 4-element quad for a fellow in Long Island, KD2AFZ. And he said, I would like to operate this quad, vertical polarization and horizontal polarization. Most people use quads, horizontal polarization. He wanted to use vertical with a switch, 2 pieces of coax, one to the vertical and one to the horizontal part of the loop. And I told him, you're going to have problems with the vertical. So I said, let's get the horizontal working first, which he did. Everything was adjusted. He had a 1.2 to SWR at the feed point, and that's what he had in the shack, because he had a very, very good a match at the feed point on the horizontal. Then he installed the vertical wire, coax. He says, my SWR is 5 to 1. I says, that's because he was feeding to get vertical polarization on a quad. A quad is a square loop. To get vertical polarization, you have to feed it in the middle of a side, of a vertical side. And that's what he did. Unfortunately, you've got the coax coming from that feed point, coming towards the mast and straight down. And the mast is metal. It's right in the vertical plane of the vertical polarization part of the antenna. So I said, you have to get a plastic mast, and you've got to also put ferrite beads on the feed line, because you got common mode all over the place. He didn't believe me. So then I told him, I said, this is how you could test if you have common mode. I'm gonna show you that in a moment, how to use your hand to find common mode. So I told him to do it. He says, yeah, when I put my hand on the coax, the SWR is jumping all over the place when I look at my analyzer. And anyway, he put beads on, and he called me and he said, it was 5 to 1 SWR on the exact same loop that on the horizontal he had 1.2 to 1. He said, I put one bead on, the SWR dropped to 3 to 1. I put a second bead, it dropped to 2. He said, I put on 5 beads, and now I have 1.2 to 1 on both. And he also put in a fiberglass mast, no more metal mast. All right. This is one way of making a coax choke. These are clip-on beads. I suggest everybody uses some type of a choke on their coax before it comes into your house. Choke it off before it gets into the shack. And the more beads you have, the better. You won't cause any problems by having too many beads. One second, we're going to take questions at the end, okay? You have any more slides? Okay. These are some of the ways that, as we mentioned before. Well, you showed this slide. This is a repeat. By the way, all the graphics are courtesy KD2ITZ, Luigi.
You didn't go over this one.
Okay. How to detect CMC? Right here. Whoops, I keep turning the green one on. What is this? A hand on the coax. Well, I'm going to show you that in a moment. MFJ makes a product with a clip-on bead here at the top. You clip this onto your coax, and it'll tell you if you've got RF floating on the outside of your coax. It's a very good, he's the only one that makes that product that I know of. And this is a picture of split beads. They also make slip-on beads, which cost a little less. But if you've already got your coax fittings on the coax, you can't use these slip-on beads. You got to put them on before you put your PL259 on. These are easier to use. These are clip-on. And these beads are not inexpensive. If you use a series of beads on one piece of coax, it might take 8 to 10 to get rid of your common mode. But there are other ways to do it where you just need a toroid and you pass the coax through the toroid a number of turns. That's also a very good way, and it's more advantageous because it doesn't cost us much. All right.
You want to switch to the
What was that?
You want to switch to the live demo?
Yeah. Okay. We're now gonna switch to a live demonstration. And what I'm gonna do here, this is as I mentioned, this is a quarter wave vertical for VHF, approximately in the 2 meter band. Here, I'm gonna turn this on. Okay, what I'm gonna do here, I'm gonna switch to over here. You see R and X down here. R and X, resistance and reactance. Now, watch the X. Let me get my pointer out here. The X. Is that X, right? I don't have my glasses on.
That's
okay.
X, yeah. Bottom line.
Now watch what happens when I put my hand on this coax. See anything changing?
Yeah.
It's moving around wherever I put my hand on the coax. Does that everybody see that? Okay. This and if I switch to, let me see here. If I switch, can you see it now?
It's better.
Is that better?
It's better than good.
Okay. This is a 2 meter vertical, cut for 2 meters. This is a quarter wave, and then supposedly another quarter wave of coax. That's how they show in the handbook. Forget it. It doesn't work. Okay? Let me show you what the SWR is. Well, I think it shows here. Minimum SWR is 6 to 1 at 150 megahertz. 150 megahertz. I cut it for 146. So now if I start, this is the antenna I said I made. I did make it 15 years ago for 2 meters, and I never could figure out what the heck was wrong. I kept adjusting the length, never get it right. I didn't have an analyzer then either. Here is quarter wave vertical for 2 meters. It's showing the best SWR, 156 megahertz. Okay. All right. So let me just check one other thing here on SWR. There is this SWR. Here it's showing SWR at this frequency of 145.8. You see it? 9.8. Look what happened when I put my hand out. It went down to 5.3. Did you see that? It's all over the place. Go try to make an antenna like that work. Okay. So what we'll do now, I'm going to show you how to correct this situation. We're going to put on another antenna.
Anybody going to the ham fest tomorrow?
Notice these two are pretty much the same length. See it? Here's the wire. Okay. So we'll take this one down. How do you like our skyhook here? Actually, I should be using a string here because I have a little screw here, and that's changing the resonant frequency. That little screw. But anyway, let me see. Okay. See, I'm putting my hand on the coax over here. Putting my hand on the coax. The SWR is not jumping around. Now let me switch over to the, let me check where the SWR is. Yeah. SWR dropped in frequency because of that screw that's on there. All right, here would show here, I have lowest SWR at 134 megahertz. So that screw made it drop quite a bit. Okay, so let me go over to the RNX. You can look at that. Here we show X is 9.7, something like that, right? Now, if I put my hand on it, it shouldn't jump very much. Where'd it go to? I can't even see it. Okay, there is a small change. You see that? It's a small, but it's nothing like it was with another problem we got. I'm getting common mode from his computer, from his cables. You see, if I move this cable, this is actually a good demonstration. If I move this cable near, see things are changing?
I should have brought the other computer.
Huh?
I should have brought the other computer.
Yeah, but, well, that's right. This is good. This is causing common mode. Okay, this is how you make this antenna correctly. This is a 6-turn choke of all it is coax, same as the other antenna, but I wound the coax 6 inches on a 1.5 inch dowel. And now this antenna will work properly.
Jay, stand back here and do that, because I think your body is
What happened?
You're re-radiating some energy to the antenna because of your body.
Oh, yeah.
Stand behind here and do that. Probably the effect will be a little bit.
But then I can't touch it anymore.
Well, yes, you need.
Let's see. How does it look? Oh yeah. Okay. You're probably right. It's not much of a change here, right?
Yeah.
Okay. All right. So this is a halfway vertical. You can make it for any band. 2 meters. Very inexpensive to make, and this is much cheaper than using those beads. Much cheaper, much less, and it works pretty much just as effectively. Okay, now I have one more antenna to demonstrate. Oh, you know, we didn't show the mobile. You still have this.
Well, yeah, I'll do that slide while you set up.
Oh, and after show that slide. I'll take this down, and I'll get the other antenna. The other antenna I'm going to show you, I'm sure you've seen it before. I've had a 5/8 wave whip for 2 meters, a mobile whip. It's a common antenna, 5/8 wave. I never tried it without a ground plane. I never had a analyzer to try it with. So I said, let me see what this does. Okay. So I put it on a ladder. Luigi made a red mark there so you could see it. It's on a ladder. It's away from a lot of stuff. This is a 2 meter commercial 5/8 vertical. Can you see what the resonant frequency is here? What it shows? 156.1 megahertz. What the hell is that? It's supposed to be for 2 meters. And the SWR was 1.26. So the first thing in someone's mind who doesn't know what's happening here, they say, oh, I got to make my antenna lower. I got to clip on a piece of wire so it comes down 10 megahertz. I want to get it down to 146, not 156 megahertz. Okay. So then I said, let me put it on my car. So here it is here. Here's the coax coming on. Look what I have here. 1.27 SWR at 145.6. The only thing I did was put it on my car. That tells you a lot, doesn't it?
Well, it doesn't. Technically, it doesn't. The radiation, that's different. That's present.
Yeah, I had no idea that antenna, without a proper ground plane, would show lowest SWR at 10 megahertz higher than it was designed for. That was quite an enlightening test. Okay, let's see. Now I'm going to show, if you read, hopefully we don't have too much junk over here with wires that might cause a problem. Okay.
Heading in the right direction. Yeah.
What? Let me take a look what we got here. All right, it's showing minimum SWR at 140. Yeah. Yeah, at home it was 146 megahertz. So this is just other things affecting it. As I look at the wires here, all this cabling, the computer, okay.
It's cooking, look, Jay.
Huh? Oh, no, it's coming up. I'm sorry. Yeah, here we go. So it hasn't shifted that much. Let's take a look here.
Hey, Jay, yeah, stand away from the antenna.
Yeah. See, my body also causes a problem. I got a lousy body.
Here, let me hit it again. Step back.
All right, good. You hit the check mark. Yeah, good. If you look at, all right, this was, what did it say, 145?
144.
142, all right.
I'm sorry, 145.1.
Okay, so that's pretty close to what I had at home. And on YouTube, there's a fellow named Stan Gibilisco. You might have seen some of he has a lot of stuff on antennas. Unfortunately, he passed away recently. But he knew a lot about antennas. And I was just doing some searching, and I saw the perfect vertical antenna. And he had a YouTube video, and this is what it was. I saw that after I put this together. This is a quarter wave ground plane for 2 meters. And if you notice, the radios are drooping. Anybody know why they're drooping?
Tell him, Vincent.
Why are they drooping, Vincent? It's not to keep the rain flowing downwards. No?
It's one of the questions.
I can only remember the
It's what?
That affects the feed point. You vary that angle.
Right.
That's a question,
Mr.
by the way, for the general.
Mr. Tarzio
exam.
is correct. I'm sure you've seen a lot of ground planes where the radios come out horizontally.
They're different length.
When they come out horizontally, you're not going to get 50 ohms. It's going to be, I can't remember now if it's 37 ohms or maybe 37 ohms. So you're not going to get a 1-to-1 SWR no matter what you do. You can keep adjusting the length of this, of the vertical radiator, keep adjusting the length of the radials. You're not going to get the SWR below about 1.5 to 1. But if you droop the radials at a 45 degree, you can get it down to 50 ohms at the feed point. And what I found out with this, if I can get this to work again, with the ground plane, it was not affected by my hand when I put it on the, let's see if we get that effect here. Let me step away a little bit. It's a very, well, actually it's jumping around, just jumping without my hand. But if I put my hand on it, pretty much the same. So this antenna, you don't need a choke. That's why I guess Stan Gibilisco called it a perfect vertical antenna. No choke required. And of course you can duplicate this on any band, 10 meters and up, as long as you have the space. Yeah, this is a terrific type of antenna. It's simple to make. You can take a look at it later. It's just with a PL259 and some stiff number 12 wire. Okay. I think I covered everything I wanted to cover. Now, are there any questions? Yes.
Yeah, I have a dipole that I feed my antenna with ladder line,
Uh-huh.
and it goes to the balance.
Goes to a balance?
No, not to a balance. My radio, the ICOM 7300,
Yeah.
has terminals for a balanced line to come in.
Your ICOM 7300 has terminals for a balanced antenna?
Right. You know, you can
That's
connect the
interesting.
ladder line right to it.
You must have a different ICOM 7300 than I have, because mine doesn't
Oh,
have.
I'm sorry. I do it through an antenna.
The what?
I do it through an antenna tube. So the antenna tube.
Yeah, you have so you have the balanced line. What is it, 450 ohm?
I don't know.
You don't know what kind of balanced line it is? And what is it connected to on the bottom end of the balanced line? It doesn't go directly to your radio, correct?
It goes directly to the antenna tube.
To the antenna. Oh, the antenna tube has got two terminals on it.
Right.
Yeah. Okay.
Do I have the same common mode problem with ladder line?
Yes, you could have common mode problems with ladder line. But what most people do to keep RF currents out of the shack when they use balanced line, I used to have balanced line coming right into my shack. I figured out a way to pass it through the wall, no problem. But I would have RFI in my shack. Obviously, I had an unbalanced situation. The way I got rid of that, I put a 4-to-1 balun on the outside wall of my shack, and I ran a 5-foot piece of coax from the balun through the wall into my tuner, into the coax socket, and that got rid of that problem.
If you think about,
Are you running?
Definition of common mode.
What?
That's really what it is. In other words, it's a common signal of the same phase.
Yeah.
On both of the both of the lines. Let's say with a balance line, if you have two signals that are a signal that is impinging on that line that's of the same phase, what's going to happen is when it gets to the balun, it can't, provided that the balun is broadband enough to handle the signal. So that's one of the advantages of balanced line. But Jay's correct. You have to have a balanced condition. If you don't, then it's
Yeah, you could have, the best way to get rid of common mode or any chance of it is with a 4-to-1 balun on the outside wall and then come in with coax.
Does it have to be 5 foot coax?
Does it have to be 5 feet?
Yeah. Could it be short?
It should be short.
Okay.
Should be less than 6 feet.
Oh.
Once you start going up to longer lengths, then you'll start having more problems.
Probably
2 feet? That's even better. Yeah. So hopefully you learned something about common mode. I certainly, when I first made that other antenna I demonstrated, and I never could get it working, I didn't even know what common mode was. But then again, when I started, nobody had such a thing called a balun in 1958. I had a 2-element cubicle quad up here in Lake Mohegan for 20 meters, right on Lakeshore Drive. It worked terrific. I fed it with 75 ohm coax because that's what I had laying around. And my DX35 had a Pi Network output. I just adjusted everything. Everything worked fine. I didn't know anything about antenna tuners, common mode. I didn't even know anything about SW. I didn't even have an SWR meter.
That DX35 was an antenna tuner.
That's right, yeah. The antenna tuner was in the output circuit. I didn't know that.
Got tube transmitters.
I didn't know that. All right, any other questions? If not, we'll turn the lights on. Vince, you can turn these other lights on. So if you want to look at any, you would like to look at any of these antennas, come right up and take a look. Thank you for attending and listening.
Please keep watching, as Jay gives a bonus presentation on the history of amateur radio repeaters in New York State.
Let's wait a couple of minutes. 2 minutes.
Then you got to entertain us. If you're up there, you got to tell us a story.
Yeah, all right, let's see. What can I tell you?
Tell us about the old days.
The old days of ham radio?
When there was one repeater in Manhattan.
Yeah. When back in 1971, somebody put up something called a repeater. I think, if I remember correctly, it was on the Chrysler Building in Manhattan. Huh? You remember that? Anyway, I'm a little hard of hearing, so if you do ask me a question, try to vocalize. That repeater was I think a 1 megacycle split, and it was the first repeater in the state of New York. They had, so I quickly went out, and when I found about it, I bought a 2-meter radio. In those days, it was all crystal controlled, so you had to order crystals from one of the international crystal company, and you'd have to plug them in and adjust them, and every time you had a different frequency, you had to get a different crystal. I think my radio had 10 frequencies. So that repeater was very active. Why? It was the only one. So they started a club, and they had over 1,000 members. 1,000 members. And they would have meetings, and not everybody would show up, but they needed a pretty big room to accommodate all the members who did want to show up. And it was a very good repeater, had very good range. I could drive all over Westchester County and get into it. I think I had a 5/8. I had 2 stacked 5/8 waves on my car. That was about 8.5 feet long. It was a very good antenna. After a while, another repeater sprung up. And the club of 1,000 all of a sudden diminished to about half. And the other repeater started a club. And pretty soon they had about 500 members. And then a third repeater came along, and a fourth. And these clubs got smaller because each club had their own members. And fast forward till today. Now we have hundreds of repeaters. And some of them are put up by an individual, and there's no club involved, and there's nobody using them. So I feel that we should do what they do in Europe. Anybody familiar how they handle it in Europe? Repeaters, 2-meter repeaters?
Well, I'm familiar with how it's done in the UK. The repeaters actually have to be individually licensed. So you have to go through the RSPB. Can I put the repeater up?
Are you talking about the 10 frequencies? Yeah, I don't know. I couldn't hear you too well, but in Europe they have 10 channels. That's it, 0 through 9, and they have a repeater in an area that covers one area, and there's no overlapping. When you drive out of that area, you'll hit another repeater, maybe channel 2, maybe channel 6. So they have it very well laid out. So all you need is a total of 10 channels, and the repeaters there, I think they're also not being used as much as we had years ago.